Welcome to Unit 5, Lesson 6, Writing Equations for Exponential Functions Practice Problems. Okay, a population of 1,500 insects grows exponentially by a factor of 3 every week. So they triple every week. All right, select all equations. All right, here's our key, all. This lets us know it's going to be more than one answer. So the first thing we're going to do is write our equation. So we get 1,500, it triples every week. So our time stands for week. Now, select all equations that represent or approximate the population P as a function of time in days. So now we have to think about how many days in a week. There are 7 days in a week. So now our equation is going to look like this. We're going to do 1,500, 3 to T divided by 7 because there are 7 days in a week. So that's P of T. And which ones look like this? Well, B looks like this. And we know from our fraction lesson from the previous video that this is 1/7 times T. And either one of them can go inside the parentheses. So D also works. Okay, so there's a lot to this problem. So tuition was $21,000. That's your A. First things first, identify your A. Your start date was 2008, and it grows 15%. Now your A also represents 100%, so don't forget that. Okay, so now let's write our equation. So 21,000, 100 plus 15 is 115, divide by 100, that gives us 1.15. But that's for 2 years. This T is 2 years. Okay, so now select all statements that describe the growth. Now we could do A because T stood for 2 years, so they divided it by 2. That works. Now, how do we figure out what the tuition cost increase? So now we got to go into the unit, into the B part. So 1.15 raised to the 1/2 power, because that's what y over 2 is, to the 1/2 power will give us 1.07238. We're going to round that to 4. We minus 1. We get 0.0724. We multiply it by 100. We get 7.24% increase each year. Now, this is the B for each year. That's the percent increase. This is the B for each year. This is the percent increase down at the bottom. I probably should have put them in. So C works. The tuition cost is not 7.5, it's 7.2. Now, the tuition roughly doubles in 10 years. So what we're going to do is we're going to put 21,000 with this A. We're going to look when X equals 10. If we use this one, T stands for 2 years, you would need X equals 5. It doesn't matter which equation you use. You just have to be careful about which B you have. So let me do that. So if I use this one, the one that's calculated to every year, my Y is, I went down when X equals 10, Y was 42, 246. If I use the other one, when X is 5, Y is 42, 239. They're $7 apart. When we're talking $42,000, they're $7 apart. So yes, the tuition roughly doubles in 10 years, and the tuition cost can be written like that since it doubles, roughly doubles. Okay, so you're going to have to do this on the quiz, so please understand why we did what we did and how we got the numbers we got. I'll put both equations into the calculator. The one calculated at 1 year and the one calculated for every 2 years. This one is a little bit of a rounding error because we know that number went on forever. So that's why I was off a little bit. Had I used a longer number, I would have probably gotten closer to the orange output for 2 years. Okay, here we go again. A, looking at the graph, A represents 10, and then B is the output of the number on the right, or the point on the right, so 1.25 divided by 10, which gives us 0.125. We divide going right to left. Now, this is look at that, that's 3 jumps. We want to get this down to 1 jump. So I'm going to show you how we're going to do this. So now, 10 to the 0.125 to the x, where this represents 3 intervals. But we want 2 out of the 3 intervals, not 3 intervals. So what we could do is divide this by 3, put it in a calculator, and then calculate 2 jumps. That's probably the easiest way to do it. Or we could just take 0.125, raise it to the 2 out of 3 jumps, get this number, and then this is our B. Do whatever way you want to do it, whatever way makes you feel fine, but it's going to be, it should come out very, very close. If I raise 0.125 to the 2 divided by 3, I get 0.25. And then 10 to the 0.25 to the x, where x equals 1 full interval. So this period of time right here. If I use x divided by 3, I'm going to get this jump, and then I'll have to calculate 2 jumps. So if I do 0.125 to the 1 divided by 3, I get 0.5. So 10 to the 0.5 to the x, where x is 1 jump. Where x is 1 purple interval. So now I'm going to put both of them into the calculator. So when a purple one jumps twice, I'll be at 1 on the graph. Y, so when x is 2, y is 2.5. Now for the orange one, when x equals 1, that's 1 orange jump. This is 1 orange jump. Y equals 2.5. So I get pretty much the same number. I get the same exact number. For different intervals, your B must be different. You cannot have the same B, the same factor, for different intervals, for different periods of time, whatever's on the x-axis. Okay, here we go. This is another culmination of everything we've been doing. Population is 10. It went up by 4. It times 4 in 2 years. So 10 to the 4, where x equals 2 years. Now, if I use this equation, I can only get 2 years. So I'm going to put this in y equals. So at 1 jump, I'm at 40. At 2 jumps, I'm 160. But remember, that is 2 years. So it's not the next one. It's all the way down here. And then at 3 jumps, I'm at 640. So now, what will we do to get this down to 1 year? All I got to do is divide. Let me do this in a different color. All I got to do is divide my time by 2 to get it down to 1 year. So 10, 4, x over 2, this equals 1 year. So now what I'm going to do is take the 4 and raise it to the 1/2 power. So I have a nice equation. 4 to the 1/2 is the square root of 4, which is 2. So 10, 2. So this is doubling every year, where this x equals 1 year. And so for doubles, that's 20. Doubles is 80. Doubles is 320. So now we clearly see, I did it better, the difference between our intervals. Our intervals our B is different for different periods of time, intervals of time. Okay, the value of a home increases by 7% each year. So whatever the home price is, let's call A1, which equals 100%. We have to add 7% because that's our increase. So y equals A times B to the x, 107 divided by 100 gives us 1.07, 1.07 to the x. Now this is each year. Now all we got to do is look, put this into the calculator. You don't need to put this 1 in. Just put 1.07 to the x. When x equals 10, what is y? Y is 1.9 and a lot of numbers after 9. 6. Let's call it 196. Well, it's actually 197. If we was to round this to a whole number, the number to the right of the 1 is 9. So this rounds to 2. So it's approximately 2. And that tells us that the factor is 2 every decade. So let's not make this x. Let's change it to D for decade. So it roughly doubles. It gets really, really close to doubling every decade. Okay, so let's look at this last question. Our coordinates for A are 1/4, so we're going to mark this down. 1/4, B is 1/2, and C is 7/4. I know that 1/2 is equal to 2/4 when I multiply top and bottom by 3. So let's make 3/4, 4/4, 5/4, 6/4, and 7/4 at C. So to go from A to B is 1/4. So all I have to do is calculate 1, 2, 3, 4, 5, 6 intervals of time. That's what we're going to do. We're going to make A our start. So 3. What's our B? Our B has to be 4.5 divided by 3, giving us 1.5 to the x power, where x equals 1/4. We're not at 0, and I'm going to show you how to get to 0 using the calculator. This is why we always put things in the calculator. So if this is our thing, all we have to do is count 6 jumps. So when x equals 6, that's what we do. Put it in the calculator. Second graph. So 1 is 4.5. 0 is 3, so this is our 0 now, but we're going to go back. I'm going to show you how to go back, and we're going 6 jumps. So when x equals 6, y equals 34.172. Let's just say 17. Let's just do 2 numbers. Okay, so we got our point for that. Now, we always want to do, since we're jumping the same interval, we can go back to 0 because a quarter is only a quarter away from 0. So just go to when x equals -1. When x equals -1, we are at 2, y equals 2. So if we want to start from 0, the better equation is 2 to the 1.5 to the x power. And you'll get the same numbers, but your things will be off by the factor of 1.5. And that's how we solve this problem.